Okay, this satellite is in a circular orbit around a planet. This planet has a radius, and the satellite is some height above the surface. And that's where a satellite is, like doing its satellite thing. Okay. And we want to know what is the orbital period. So let's do like a map of where we're going with this. So velocities change in distance over time. I want to swap those. You know what? I'll go slow. I'm going to multiply both sides by time to get rid of the time on the bottom there. Then I'm going to divide both sides by v. You can actually just swap the v and the t because this will always be true, but if you need to do that middle step, that's okay. So the time period of one revolution is a circumference, 2 pi r, over our velocity. They gave us a velocity. We'll have to find r, and that's going to be super annoying, but we can do it. So the r is the radius of the full journey here. So it's this full thing. That's what we got to plug in over here for this r. So we've got some math to do. First up, they give you a diameter. So we need that to be a radius. So the radius of planet is going to be half that. So 3.2 divided by 2. So that's going to be 1.6 times 10 to the 6. First of all. Sorry, 1.6 times 10 to the 6. And then this height here, so that's 1.6 times 10 to the 6 to the 6. That height, they gave it in kilometers, which is so annoying. So we got to get that in meters. So 4,800 kilometers, kilometers over 1. There are 1,000 meters in every kilometer. I can't talk and do this at the same time. Hold up. Sorry, that's all just a mess. Let's try this again. Basically, you have to multiply by 1,000 instead of dividing by 1,000 like it might feel like you should. When in doubt, this always works. Multiply by 1. You can multiply anything by 1. So if 1 kilometer equals 1,000 meters, you can multiply by that. So we need to multiply this by a lot. So 4,800 times 1,000. We add 3 zeros. So 4,800 plus 1, 2, 3 zeros. So that's 4,800,000 kilometers. So 4,800,800. So that full radius, that orange one that we got to plug in here, we have to add those up. So that plus 1.6 e to the 6 is a big number. So I'm going to do my orange again. So r, the total, equals that r plus that h, so that's 1.6 times 10 to the 6 plus 4,800,000 equals 640. Okay, so 6,400,000 meters. Okay, so that's 2 times pi times 6,400,000. And our velocity is 6.5 times 10 to the 3rd. Times 2 times pi divided by 6.5 e to the 3rd. Okay, so this is 6186.5 seconds, which is none of our choices. So again, we multiply by 1. You're always allowed to multiply by 1. So there's 60 seconds in a minute, and 1 minute has, 60 minutes are what's in 1 hour. So we're going to take this number, divide it by 60, hit enter, divide by 60 again, and hit enter. So this ends up being 1.7 hours. Do we need to go to days? No, we're good. We could have done it again, going from hours to days to see if we needed to, but we got to stop early, so that's good. So that's how you do that one.